Alright, Amina, as promised, here's a quick video on law of sine stuff for you. First off, notice how cool I wrote your name. It's like a giant scribble, but it actually spells your name. I think that's pretty cool. So we're going to talk about the law of sines. This is the basic triangle we're going to use for our models. Capital A across from lowercase a, capital A being an angle, lowercase a being a side. And that will be the same when you look at it in the formula, law of sines. So first off, law of sines should be used when you know one pair of opposite information. So say I know side A and angle A as well. That is what I mean when I say opposite pieces of information. You need to have one full set of opposites, meaning you need to know one angle and the opposite side, and then to use the law of sines, you just need to have one other value. Maybe I know B, side B, and then I could use that to find angle B. Or maybe I know angle C, and I could use that to find side C. You just need one full set of information and then one other piece of information to use the law of sines. This is the basic setup of the law of sines. So again, let's say we know one angle. Let's say we know angle A, and we know side A, and we know, let's say, angle B right there. Well, first off, what can we find? We'll match up the opposites. Those go together, and then B will allow us to find side B right there. Angle B allows us to find side B. So if I was setting this equation up, let's say I know these values as angle A is 15 degrees, angle B is 72 degrees, and side A is 13 units long. Then I would set it up just like this. I'd put side A right here as 13. I would put angle A underneath it inside of the sine function as the sine of 15, and then I would put that angle inside of the sine of B, 72 degrees. And we can ignore that for now. That's just showing us that this relationship holds true for each set of opposites. But I would want to get B by itself to know what it is, so all I would have to do is multiply it by the sine of 72. And then I have B by itself. Notice that the value we wanted to find, the unknown piece of information, aka side B, we put in the numerator. You can set this equation up in two different ways. I could just as easily set this equation up with my fractions written like that, with the sign of the angles in the numerator and the sides in the denominator. So it all comes down to what pieces of information you have. Let's say I know that side C, angle C is 32 degrees. I know side C is 18, and I know side B is 27 units long. Well, then in this case, since I'm going to be solving for angle B, I'm solving for an angle, I want to put the sine of the angle in the numerator, because then it's less work to solve for it. So whatever variable you want, that's what you should put in the numerator. So I would match this up. I know that angle C is 32 degrees. I know that side C is 18 units long. I know that side B is 27 units long, and I don't know what B is. So in this instance, again, I would multiply that 27 up, but now I would have this expression, sine of B equals 27 times the sine of 32, all divided by 18. Well, I want angle B, not the sine of angle B. If I have the sine of angle B, how do I get angle B? Well, sine inverse. So angle B is going to equal the inverse sine of that entire expression. 27 times the sine of 32 divided by 18, all inside the inverse sine function like that. Let's look at two problems. Let's say we have this problem right here. We've got a triangle. We know one side and two angles, which means we're going to be solving for an unknown side. So let's match up our opposites. we've got 137 degrees, straight opposite of a side length of 8.7. Okay, what's my other set of opposites here? Well, my other set is this 27 degrees and side A. So, since I'm trying to find side A, I'm going to set this fraction up with A in the numerator. So A over the sine of 27 equals, since I put the side in the numerator, I need my other side in the numerator, 8.7 over the sine of 137. And what do I want? I want A, so I need to multiply by the sine of 27 on both sides. So I will get A equals 8.7 times the sine of 27, all divided by the sine of 137. Plug that into your calculator and you have your answer. So, hit the on button to turn it on. First off, check the mode. Make sure you're in radian mode. You should see it 1, 2, 3 down. It'll say radian and degree. I'm pretty sure I just misspoke and said make sure it's in radian mode. I meant to say make sure it's in degree mode. So use the arrow button to put the cursor on degree and then hit enter and you will be in degree mode. So make sure you do that first. Once you know you're in degree mode, I would recommend you enter it just like this. Hit 8.7, doot, 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 and then I wouldn't even type anything else. I would just press the sign button, and that will put an SIN with a parenthesis right there. I would type your 20 and your 7. You need to close this parenthesis, close it like that, then divide by, hit the sign button again, the sign, it will give you that parenthesis, and type 137. Boom, boom, boom. Doesn't even matter if you close the parenthesis or not, but you can if you're nervous. Hit enter, and you should find 5.791. And again, that is side A, 5.791. Now, if we wanted to completely solve this triangle, we could take 180 and subtract 137 and subtract 27 again. That would give us 16 for that angle right there. And then we could do the same thing to find side C. But look how easy it actually is. The only difference here is instead of using that angle 27 degrees, angle side C, we need to use the angle from angle C, which is 16 degrees. But if you plug that in, you will find C, and that value should be 3.516. And little tip, if you have just done this calculation here, if you hit second and then hit enter, it will retype what you just typed. And then you can use the arrows to go back up and change the 27 to a 16, hit enter again, you have C in a jiffy. Now let's look at the other case, where we know two sides and one angle. And let's use this to find the only thing we can, angle B. So, since we're searching for an angle, we're going to set up our expression as the sine of angle B, the thing we want is in the numerator, divided by the thing that is opposite of that, which is 19.821, equals the sine of some pair of opposites that we know. We know the angle is 13 degrees, and we know the side opposite of that is 22. So we need to multiply up by that 19.821, and we will get the sine of B equals 19.821 times the sine of 13, all divided by 22. But we do not want the sine of B. We want B, so we need to hit B equals the inverse sine of that entire ugly mess. 19.821 sine 13 divided by 22. Okay, and now let's enter that into our calculator, and I'll show you how I would type it in. I would hit second, and then I would hit the sine button. That will give me the sine inverse function. It will give you a parenthesis. Now I'm going to type my 19.821, 19.821, and then I'm going to hit the sine button again. It will put sine there. Notice I didn't even hit multiply, I just typed the sine button. It gives you that first parenthesis. I'm going to type 13, and now I have to close that parenthesis, but only close it once. If you close it twice, you will be closing off the sine inverse function, and we're not done yet. We still need to divide by 22. 2. And now you can close the parenthesis off if you want to, but you don't have to, and you should get 11.693, and remember what that is. That is angle B, 11.693. So this diagram is clearly not to scale, but now that you have those, you can find that third angle, 180 minus the two of those, and then you can find side A, setting up another law of sines proportion. Have an awesome weekend. I'm out.